Okay, this is another paper, the latest paper, February, March 2023, 9702, paper 42. So a look at the question number 1. I have solved already for you just to save your time. So look at this. Question number 1, A part. Define gravitational potential. So we have to remember this definition. Work done per unit mass to move it from infinity to a point in the gravitational field is called the gravitational potential, which has formula phi is equal to minus gm over r. And r is actually the distance from the center of the planet. Next, Artemis is a spherical planet. They may be assumed to be isolated in the space. The variation with the distance x from the center of the Artemis of the gravitational potential is shown. So at the x-axis, this is the distance from the center of the planet. And at the y-axis, there's a gravitational potential. So the gravitational potential inside the field is negative. So whole of the graph is plotted below 0. So here, these are the negative values. And the question is, the radius of the Artemis is 4,800 kilometers. Determine the value of phi on the surface of the Artemis. So look, surface of the Artemis. So this is the value, this one. So its value is this, which is 3.55 into 10 power 7 joules per kg. You can read it from the graph. Next, show that the mass of the Artemis is 2.55 10 power 25. First, write the formula. And then m is equal to phi r over g. You can ignore this negative sign. So m is equal to this phi at the surface is equal to 3.55 10 power 7. And the radius is given in kilometers into 10 power 3 for the meters divided by value of g constant. You will get the same answer, which is required. Next, the gravitational field strength of the surface is required. So the value of the g, the formula for the small g at the surface is gm over r squared. So g value, mass we have calculated for this Artemis, and this radius in meters, 4,810 power 3 per square. So you will get this answer, the value of the g, 7.38, or you can write 7.4. Both are acceptable. Next, a satellite is in the orbit at the fixed position above the point on the surface of the Artemis. The satellite is located above the equator of the Artemis at the height above the surface, where the gravitational potential is 0.65 into 10 power minus 7. Okay. So phi is equal to minus gm over r. So this is a value given. G value, m value, you can calculate this r, which is 2.6 into 10 power 7 r. The other method is, look at this value, 0.65 into 10 power 7 from the graph. So here, and this is actually the radius. So you will get the same answer. Either calculate it or read it out from the graph. So you will get the same 2.6 10 power 7. So it is coming close to 2.7 into 10 power 7 or 2.6, both are acceptable. Then from the Kepler's law, T square is equal to 4 pi square over gm. This T is required for pi value, and this R, which is calculated, is 2.6 and 10 power 7 whole power 3, G and M. You will get this answer, which is approximately 18 hours. These are the seconds. Then you have to convert it into hours by dividing by 3,600. Next part is state one similarity and one difference between the gravitational potential due to the point mass and the electric potential due to the point charge. Similarity. Both are inversely proportional to distance. This is a similarity. But the difference between gravitational potential and electric potential, gravitational potential is always negative within the field. But electric potential can be either positive or negative, because for the positive charge, it's positive. For the negative charge, it's negative. So this is the difference. Now move to the question number 2. State what is meant by ideal gas. We have to remember this definition. A gas which obeys all gas laws, PV is equal to nRT for all values of pressure, volume, and temperature. But do remember, temperature must be in Kelvin. Next, a fixed amount of the helium gas is sealed in a container. The helium gas has a pressure given 1.1 in 10 power 5. This is the volume. This is temperature. The volume of the container is rapidly decreases to 30. The new pressure is given, new temperature is given. Both are given in these boxes. And the question is, no thermal energy enters or leaves, mean the delta Q is 0, plus minus Q is 0. Show that the helium gas behaves as an ideal gas. So we will calculate P1, V1, or T1 for the first situation, P2, V2 over T2 of the second situation. After the change of the volume, both answers are coming same. It means the gas is ideal because P1, V1 over T1 is constant. It means the gas is obeying all gas laws, so it's ideal gas. Next, first law of thermodynamics may be expressed as delta UQ plus W. Use the first law of thermodynamics to explain why the temperature of the helium gas increases. Look, this Q is 0. So change in internal energy exactly equal to work done. As volume decreases, work is done on the gases. When the work is done on the gas, so internal energy of the system increases, and internal energy is equal to total kinetic energy, which is 3/2 nkt. When internal energy of the ideal gas increases, hence its temperature increases. Next, the average translation kinetic energy of the molecule is given 3/2 kT. This is a kinetic energy of one molecule. Calculate the change in the total energy. So first we will calculate the number of the molecules. PV is equal to nkt. N will be PV over kT. So you can take any information. Suppose we take this first one. So it's pressure, it's volume, but you have to convert this in meter power minus 3. This is K, and temperature in Kelvin. This is the number of the molecules present in the gas. Then average kinetic energy total, 3/2 nk delta T. So change of kinetic energy required. So we'll use here change of temperature, 3/2 number of the moles, number of the molecules, K value, and then the change of temperature. So answer is coming 212 Joule. Next is the mass of the nitrogen gas. Another container is 24 gram at the temperature of 27 degrees Celsius. The gas is cooled to the boiling point minus 196 degrees Celsius, assuming all the gas contents to the liquid. For this change, the specific capacity is given, latent is given, determine the thermal energy. So the gas is changing temperature as well as state. So for the change of temperature, mc delta theta, for the change of state, ml. So mass in kilogram, specific heat capacity, and change of temperature. 24, change of the temperature is, 27. This is 27. So the 27 minus this minus, so the total change is this, plus m mass in kg, and the latent heat, when you will calculate, the total answer is coming 10.3 into 10 power 3, mean 10 power 3 kilojoule, because the answer required in kilojoule. Question number 3 is an object is suspended from the vertical spring. The object is displaced vertically and then released so that it oscillates, undergoes simple harmonic motion. Figure shows the variation with displacement x of the energies. So this is the total energy, and this R is the kinetic energy, and this is the potential energy. And the question is, the kinetic energy, the potential energy, and the total energy are each represented by this. So state the energy that is represented by PQR. P is total energy, Q is potential energy, R is kinetic energy. And then the object has a mass 130 gram. Determine the period of the oscillations. We will use this formula. Total energy is equal to 1/2 m x naught square omega square. And the total energy from the graph is this, which is in millijoule. So we will write this value over here, and it is 6.4 10 power minus 3 from the graph, 1/2, mass in kg, 0.13, and this x naught from the graph, this is the displacement, but in meters, so 10 power minus 2. So 1.5 10 power minus 2, it's square, omega square. Omega square is 438. Omega will be 20.9. Then we will use the formula, time period 2 pi over omega, 2 pi divided by 20 by 9. So answer for the period is coming 0.30. Next state, the cause of the damping. So definitely damping is decrease in amplitude due to loss of energy, and the loss of energy due to the resistive forces. So the cause is the resistive force, which is in the opposite direction to the motion. A light car is attached to the object. The object is displaced with the same initial amplitude and then released. During each complete oscillation, the total energy of the system decreases by 8%. After total energy at the start of that oscillation, determine the decrease in the total energy after 6 oscillations. So look, if loss is 8%, then the remaining percentage is 92, mean 0.92. And there are 6 number of oscillations, so the remaining energy is 0.92. 6 times mean we have to multiply 0.92 6 times, so its power becomes 6 times 6.4, which is the initial energy. Look at this, initial. So we will get the energy remaining. So the loss energy will be the initial minus remaining, which is coming 2.5 millijoules. So first you have to calculate the remaining energy, and then you have to subtract it from the initial, then you will get the loss of energy. So after each oscillation, 0.92, after first, 0.92 of energy first, and then after second, 0.92 of the first 0.92 E naught, and so on. So we have to multiply this 0.92 6 times, so 0.92 power 6 of 6.4. This is the remaining energy. The state with a reason. The type of the damping that got introduces into the system is a light damping because the amplitude decreases gradually 8% in each oscillation. So it's gradually decreasing. So it's a light damp system. State Coulomb's law. Yes, electric force is directly proportional to the product of 2 point charges, very, very important point charges, and inversely proportional to square of the distance from their center. This is the Coulomb's law. A charged sphere X is supported on the insulating stand. A second charged sphere Y is suspended by the insulating thread so that the sphere Y is in equilibrium. Okay, it means sphere Y is at this position. It is at rest. Charge of the X given, charge of the Y given, this mutual distance given, this length given. And the question is, the length of the thread is this, and horizontal distance is this. On the figure, draw the label. All the forces, look, the weight is acting down, tension here, and the repulsive electric force on the Y is this. Determine the mass of the sphere. Look, the weight is down, force in this direction, tension in this direction. So first we will calculate the angle. So sine theta perpendicular over hypotenuse. So theta is equal to sine inverse. This distance is given 0.08, this one. And this hypotenuse is given 1.2. So we will calculate angle from these two values. 0.08 divided by 1.2, this is 3.8 or 3.82. Now, if this is the angle 3.82, then perpendicular over base is tan theta. So tan of 3.8, this perpendicular is the electric force and this weight. Because mass is required, so definitely for the mass, we have to first calculate weight. So weight. Now, this force, this one electric, is actually 1/4 pi epsilon naught, or just K is equal to K times Q1, Q2 over D square. K constant, mean 1/4 pi epsilon naught, whole value is 8.9, 10 power 9. First charge is 96 nano, other is 64 nano, mutual distance this square. So this is the electric force. Now use this equation again. So W is equal to F divided by tan 3.82. So F you have calculated from the formula this, tan this. So weight is coming this. Now weight divided by the value of G's mass. So the answer is coming 0.12. So in this part, first we will calculate the angle. then we will calculate the force electric, and then by using this equation, tan theta P by B, mean tau F divided by W, this mass is calculated. Calculate the total electric potential energy stored between X and Y, just 1 mark. So energy is work is FD, so F electric is this, and the distance of the repulsion is 0.08, so this answer for the energy, Joule. And next, an electron enters a region between the two parallel plates P and Q that are separated by the distance of 18 millimeter. So there is electric field, and this is the direction of the electric field. The space between the plate is vacuum. Potential difference between the plates is 250. The electric potential must be assumed to be uniform, okay? And the lower potential is 0. State the direction of the electric force on the electron when it is this. Okay, look, suppose this is electron, so it's negatively charged. Definitely it is attracted by the positive plate. So we will write here towards the top plate, mean towards the P plate. Look at this. Determine the magnitude of the force acting on the electron. F is equal to EQ, and E is equal to delta V over D. So delta V potential difference is 250, and the charge of the electron is this, divided by separation is this, because it is 18 millimeter, so 18 10 power minus 3, so 2.2 10 power minus 15. This is the electric force experienced by the electron. Explain why the electron does not follow the circular path. Look, this electron is traveling in this direction. All the time, angle is not constant. Angle between the path and the force is changing. So we will write here, electric force is not perpendicular to the path of electron. Thus, this path is not circular. It's not circular. Next, question number 5. A capacitor, a battery of EMF 12 and resistor R are two-way switch are connected. The switch is initially in the position S. When the capacitor is fully charged, the switch is moved to the position T so that the capacitor discharges at time T. After the switch is moved, the charge on the capacitor Q, the variation of Ln log Q. Look, the charge in microcoulomb, but Ln is calculated, and then graph is plotted against T. Show that the capacitance of the capacitor is 1.5. So we will take first initial charge, which is Q naught, because when it is fully charged, its charge is Q naught. So initially, because this time is discharging time, so we are using time 0, because at time 0 discharging time, it is fully charged. So this is the full charge value, but this is actually in terms of Ln. So Ln Q naught, which is in microcoulomb, is 2.9. So when we will shift this Ln over here, it becomes Q naught microcoulomb e power 2.9, and e power 2.9 is 18.2, but the value is with micro. So the initial charge is 18.2 into 10 power minus 6. So it's the first step. So we will take the value of the y-intercept when time is 0. We will convert this into the actual charge by taking anti-ln exponent e power 2.9, and this is the charge. Now, Q is equal to CV. So C is equal to Q by V. Q is calculated, and the voltage total supplied by the battery is 12, hence shown that its capacitance is 1.5 microcoulomb. Next, determine the resistance of R. Look, during discharging, Q is equal to Q naught multiplied by e power minus T over RC. R, you can use this equation. So when we will take Ln both sides, so Ln Q over Q naught, so it becomes T over T naught times Ln E, but Ln E is 1, so we can ignore it. It becomes Ln Q over Q naught is equal to minus T over RC. Now, this can be written as gradient is equal to ln q over q naught over t, because gradient is equal to change in the y-axis divided by change in x-axis. And do remember, this can be written as ln q minus ln q naught, mean y2 minus y1. So this is actually y2 minus y1 divided by x2 minus x1 time. So it becomes the gradient. So the gradient is equal to, so when t comes over here, this whole becomes gradient. So the remaining is 1 divided by RC. So this minus 1 over RC is actually the gradient. So we calculate the gradient first, y2 minus y1, x2 minus x1 from the graph, 2.9, 1.9, this is 1.4. So the gradient is 1 over R. So R is equal to 1 over gradient of C. I just put the value of this gradient 0.25, 1 by 4.25, 1 divided by R required, and capacitance you have calculated. So this is the value of the R. I repeat this. This value, this one, it can be written as ln q minus ln q naught is equal to minus t over RC. So ln q minus ln q naught over t is equal to minus t over, sorry, minus 1 over RC. So this is gradient. It means the gradient is minus 1 over RC. And the gradient is the graph is already negative. So we can ignore this negative. Our negative is cancelled. So the gradient is equal to just 1 divided by RC. So we will substitute this gradient 1 over RC after calculating this gradient. So you will get this resistance. Calculate the energy stored in the capacitor. Energy is equal to half QV, half charge we have calculated. And this is the voltage at time 0. At time 0, you have calculated the charge over here, 18.2 10 power minus 6. So use this over here. And the value is 1.1 10 power minus 4. Now the second identical resistor is now connected in parallel with R. When resistor is connected with parallel, resistance decreases. Look, time constant RC. When R decreases, time of discharge also decreases. So the question is, sketch a line ln q in microcoulomb with the time t0 to 5. So look at this. So we will start the same charge, same ln, and then after 4 or 5 seconds, you can take this up. So this time is taken. So it's a graph. So after calculation, you can draw this new line because resistance becomes half. So the time becomes half. Okay.